So we are live. Thank you everyone for coming to another NOSP event. I'm Ricardo from NOSP. Together with me, it's Derek and Odd, and I'll present the rest afterwards. We are very pleased that you come over. I see some presenters come a long way for this presentation, so special thanks for that. I'll be doing a short presentation. Our chairman couldn't join tonight. Stuart got a little bit sick, so I'm taking over the presentation. We will have 4 presentations throughout this event. There will be some food and so on, but I'll pass these details to Stig after. He will guide you a little bit through that. And I will just pass on here with my presentation. Yeah, I think first of all and foremost, these are our sponsors for still for last year. This will be updated soon when we get time to review who's going to be a sponsor for NOSP. As you know, we have now back to the fine of the after COVID fee. There are 33 sponsors, and we can thank them for all these events that we are having throughout the year. For of course the food and everything. This will be updated, yeah, like I said, hopefully before the next event. Yes, so this is our first time at Innova here. We typically do our events in hotels and so forth, but we thought this is a very nice place and also to present some interesting gadgets that you have at Innova. And we have a quite nice area, quite nice workshop. So I hope you have a good time tonight here at Innova. For the persons that are new to NOSP, I can revise again. So Stuart Duncan is our chairman. I think he's sick, but he should be following us on YouTube. Hello, Stuart. Hope you get better. I'm Ricardo Ferreira. I do part of treasury and a lot of other stuff. John couldn't join as well. He's from Fugro. Derek Yardin from Subsea 7. He's sitting here next to me. And Ott Knudsen from UTech Survey. He's there in that corner. And here's an overview of our events. So this is the first, and then we have also, actually there is one missing there. I can see we have already had one beginning of the year. We will have another one in Bergen in 11th of May. The theme we still need to adjust a little bit. The theme will go and try to fine-tune the theme according to the actual interesting presentations that we have. That would be then in May 11th, and then we have the traditional, in August 31st, the traditional Subsea Innovation Day at Opera with the theme of autonomy. Not sure exactly what's going to be of autonomy, but there is a lot of autonomy nowadays ongoing in the market. So I guess most of the companies have something to say about autonomy. And then we are back to Bergen in November 12th with Argo's remote systems. And we end up the year with our typical annual dinner in Stavanger. I think I can say this time that we are settled for a new location, but I'm not going to say more just to create a bit of enthusiasm and suspense here. It's not going to be the same place, of course. Yes, So this is the flyer we got. We got 4 interesting presentations. We start with Sonardin, Alan McNolan, and then Voice, Sean Elmer. Then we're going to have a half an hour break. So if you didn't fill up your stomach, you have a second opportunity. Hope you keep things there. And then you have 2 sessions of Fostech with Stephen Foss, and to end we will end with actually Innova with Terje. So there will be then a small workshop afterward. Like it's a demonstration of the equipment. That's it. So this is from my side. Is almost it's everything. I'll be here from time to time helping up with the laptop and so forth. I think now I'll pass the word to Stig to have some words welcoming to Innova and so forth. Stig, you can use the microphone or you can just talk loud as you prefer.
Well, I'm pretty good at talking loud. But anyway, welcome to Innova. My name is Stig Olsen, Sales and Marketing Director. This is the first NOSP meeting we host here at Innova. I hope it will not be the last, of course. I would like to provide some practical information in case of emergency. The muster point is at that side building towards SFF. Toilets are in this first floor and also second floor. Regarding the workshop, it will be a little bit amputated. We would like to take it down to the workshop, both downstairs and also up here. But due to ongoing work, heavy workload, and restrictions related to confidentiality, we cannot do that at this time. So, but we will demonstrate our multiplexers and some survey equipment. We can do that maybe during the breaks, but we are planning to do that at the end of the program around 8 o'clock. So that's it from me.
All right.
Yep.
Thank you very much, Stig. Let me see it, jungle a bit here with the microphone. We also have, I see in the audience, quite some students. So welcome. I'm very pleased to see you all here. Last time in Bergen, we also had quite a good audience of students. So that's one of our incentives at NOSP, is to introduce the students to the market and to introduce the students to the technology and to make that process easy for the students. So you can see them well identified with that was smart with blue sweaters. Everyone can talk to them. And vice versa, students, feel free to be active and present yourselves towards the others. Yes, so I'll leave you with my talking. I think I will just pass you to our first presenter for the Sonardin, Alan McDonald. Alan, I will put here your presentation ready. And there you go. Do you want to use the microphone or? Yeah. Okay. There you go.
Thank you, Ricardo. Thank you, everybody. And nice to be back in Stavanger after quite a while. So my presentation is on next generation system architecture. I'm going to have to put a disclaimer out here first. I'm not a hardware engineer. I'm not a software engineer. I'm one of the Sonardin sales guys, and it was our technical director who was meant to do this. And he came up with a theme to tie in with the Internet of Things kind of overall theme for this evening. He bailed out, as directors tend to do, and leave the employees to do all the hard work. And he sent me 5 slides, and I said, "That's not 20 minutes worth of talking there, Daryl." He goes, "So figure something out yourself." So I have done. So what I'm going to do is go through a bit of kind of history before, or where the hardware is, or was when I was offshore many years ago. And give you an idea of where Sonardyne's going. And it's not just where we're going. There's a lot of companies kind of going down this route, trying to make things subsea a lot easier for the end users with how equipment's used, how it connects to each other. And there's a lot of collaboration in the industry to do with things like wireless comms, which we are involved in, that we're trying to get kind of move forward a bit. And what we're going to be developing in the future kind of ties into that. So it does fit into this kind of Internet of Things idea. If anybody asks any question to do with Ethernet protocol, I'm going to say, don't know. I'll get that out of the way right now. Just don't even think about it. Because you'll make me look stupid, and that won't be a good idea.
Sorry to interrupt. I forgot to press a button because we are actually live on YouTube, and I forgot to press on the share button. So if you want to keep it confidential, I just don't press it.
No, it's all right.
Is that right? Okay. And there you go. Thank you.
We're live now.
Apologies for that.
Right. So for those joining us on YouTube, you just missed the best 5 minutes ever. So on with the presentation. If it would go forward. Oh, what's going on?
All right, let me help you with that. Oh yeah, I screwed the whole thing here, didn't I?
You all heard that, not my fault.
Typical.
I have to do everything on one slide, not 5.
And there you go. And then if you press left and right. And there you go. I saved the night, didn't I?
Yeah, so a little bit about me. So I got a degree in electronic and electrical engineering, but that was back in the analog days when real men did real electronics with resistors and capacitors and stuff that you could solder without destroying PCBs. So I'd had four years there. If you can see the picture there's a lot of students getting drunk. I'm sure all you guys from the university don't do that. I'm sure you study very hard. That's good. Don't do what I did and forget that 4 years. After graduating, I went to work for Subsea in Aberdeen as an MWD and LWD engineer. And that's 4 years I wish I could forget. Things happened in that 4 years I still can't talk about. So after that, escaping Subsea, I went to work for TSS. They're now part of the Teledyne Group. There's some people in there might recognize that ROV. I was actually one of the development team of the TSS 440 pipe and cable tracker. And that was one of the trials with Deep Ocean back in 2001 or 2002. So I was 10 years with them. And then back in 2009, I went to work for Sonardyne, which is where I've been ever since. So I'm sales manager for the Northern European region in Aberdeen. Mainly doing all the kind of acoustic stuff, the LBL, USBL, and some of the subsea robotics. So I'm also on the committee of the Hydrograph Society of Scotland, which is roughly the same as what NOSP is here. Even though I'm not a surveyor, I organise the fun stuff like the golf day and the quiz night. There's no survey experience required for that. A little bit about Sonardyne. We're a private company, still owned by the same owners who set it up almost 50 years ago. We've got 4 main offices around the world. So we're headquartered in the UK, down the south of England. I work in the Aberdeen office where the real work gets done in the UK. and we have offices in Houston, Mackay, and Singapore. Our main kind of product or markets is energy. We used to say oil and gas, but that's a dirty word or dirty words. So we say energy, and we put in pictures of windmills to give us our green credentials. Well, the last year for anybody in this industry, I'll say, oil and gas has been quite profitable for us. So that's been our main business for the last 50 odd years. Defense, we do a lot now, more so underwater defense space, intruder detection and things like that, which has become a lot more concerning to people since February last year. And we've got some ocean science stuff as well that we do with research institutes around the world. So that's our main three kind of business areas. So we're part of the Clavelia group, which is essentially Sonodyne, just by a different word. And there's other companies we've got there under the Clavelia umbrella. We've got Voyas, Sean's there from them. We've got a few others. So that's the group of companies we represent. So a little bit of what I'm going to talk about, a little bit of where we are now, where we want to be, how we're going to get there. A little talk about interoperability, which is a big subject, especially in Norway with what Equinor are trying to do with their subsea drones. And then just a final slide on why we're doing this as Sonodyne. So hardware evolves over time. In the case of Sonodyne, going back 20 plus years, we had a thing called a Mark IV Compat. Maybe some people here might remember them. I don't. I'm too young for that. That evolved into something called a Compat 5. So we went from 4 to 5. That brought in, that was about 20 years ago, that brought in digital acoustics. Before, subsea acoustics were based on tone. It was always like Morse code underwater. We brought the Compat 5 out with our digital acoustics, which moves from kind of a Morse code based signaling system to something that's like text messages underwater. But 2010, we went with the Compat 6. So 4 to 5 to 6. We're not very imaginative when it comes to naming our products. We just increment the number one until we got to this one, which is a 6 plus. The idea being it wasn't a big enough change to make it a 7. So we just came up with a 6. But that brought in another level of digital acoustics. So the yellows was our first generation. The reds was the second. The grey ones brought in the third. And that's where we are now. So where we're going is what I'm going to talk about. And I've just got to completely put people's minds at rest. This is not a Compat 7. So anybody who uses Compats, I'm not talking about that. I just used that as an illustration of the development. There is no Compat 7 yet. So in my days offshore, thinking about how things connected and how we kind of wired things together, it was, I wouldn't say simpler time, but it was challenging because we had different communication schemes within equipment. For hardwired umbilicals, so solid copper umbilicals, we would go with 2-wire or 4-wire current loop kind of comms, which were notoriously unreliable. If the umbilical capacitance was too great, these comms just died. It became a real problem, especially when trying to fault find offshore. I'd go on a boat, get shouted at by the party chief. I'd say, sorry, but your umbilical's not good enough. He'd say, no, it's not, it's your equipment. I'm going, no, it's your umbilical. It's your equipment. So it got into a bit of a kind of boxing match there. When multiplexers came in, we started looking at serial comms. So you're looking at RS-232, then kind of 422, 485, half duplex, full duplex, things like that. And then power was another problem. You know, you always had different powers available on vehicles, 24 volts, 48 volts, 110, 115, 120. You just basically turned up to install a bit of kit and hope for the best and try not to blow things up. But every offshore engineer, when I was doing it, always carried a pocket full of null modems. Always carried RS-232 to 422 converters. You never knew. And then you'd have to try and figure out how to wire something in. So I guess what I'm trying to say is, in the good old days, it was an absolute nightmare. And this is kind of where I'm the point I'm trying to get to with the presentation is, looking at if we standardized all this, things become a lot easier. So that's going to be the general kind of a message of this presentation. So if you look at a kind of typical survey spread at the moment, and I've chosen our USBL system and some inertial stuff just as an illustration. So you've got a top side bit of equipment, that blue thing there, and that's kind of running the software for the USBL and the INS system. And you can see all the different messages that are flying around to make this work. You've got your GNSS, which is providing position, speed, and time to everything on the vessel that needs it. You've got PPS from the GNSS. We're throwing that down into the ROV to the inertial sensor, which is that little kind of box there. That's our Spirit Nav Mini INS and DVL. That's sending messages back up to the top side. We're sending stuff down to that to give it a position reference from the USBL. The USBL transceiver is pinging a beacon on the vehicle. The USBL needs heading, roll, and pitch to correct for vessel motion. So we've got an AHARS next to it that's feeding out more data. That data is then getting fed into a third-party survey software. In this case, one of IVAS is our sister company. So you can see there's a lot of things to wire up. And if something goes wrong, there's a lot of fault finding. You could have a dodgy cable. You might not have the right drivers and software for one of these data telegrams. There's a lot of information going around that everything needs to speak to each other and try and make sense of what's going on. All these sensors have to be powered as well on the vehicle. So what we're trying to do in Sonardyne and a lot of other manufacturers is make that a lot simpler. And how we think it'll work is by basically running everything over an Ethernet. So this is where we kind of want to be going forward, is that we make things a lot simpler, a lot less complicated, and a lot easier for the end clients to get up and running and to use. So the first thing we need to do, if we're doing everything Ethernet based, is to look at power. Now, there is a thing, power over Ethernet. There is various schemes of it. We've implemented that already in a couple of our devices. And the plan is over time is to implement it into all of our Subsea products. So it's simply Ethernet is able to power a connected device. There is limitations with it, which I'll get to. And why we do that? Well, you can see there's cost savings in the installation. Everything becomes a lot cheaper to do it that way. We're not looking at specialized connectors that can handle heavy power or fancy cabling. It becomes quite simple. It's flexible, so there's a lot of kind of flexibility built into how you install these things. Centralized power management, well, it's all run through the Ethernet system, so there's no real power management. It just has to be able to deliver the amount of wattage needed for the connected devices. And in theory, there's fewer points of failure. And I guess that's the important one, is that you're taking out a lot of potential failure nodes that can muck up. A complete service spread on a vehicle is quite a complicated system. So if you take out as many failure options out of that as possible, it makes life easier for the guys working offshore. So we've already implemented one of the power over Ethernet standards, and it's the PoE Plus. So there's a couple of our new products already have that, the Micro Ranger USBL system and a new thing called Dive Track. And PoE Plus allows for about 25.5 watts for the connected devices, which works for most of our kind of low-powered acoustic products. There is some power over Ethernet standards that deliver higher wattages, and that's something we'll probably look at in the future where we go with that. So that's the first thing we had to look at this kind of big kind of system idea is the power. So what the next thing we're going to try and do is take away the top side computer systems. And the way we're going to do that is embedded software. And again, a couple of our products already do this. But that's basically, if they're on the Ethernet system, you connect a laptop to any Ethernet port and you just connect direct to the device and you run its embedded software. There's no need to download or install software on the computer. You just type in the IP address of the connected device and the software already embedded in there. That means you don't have to worry about PCs crashing, interface boxes kind of dying. It should become a lot easier. And upgrading becomes a relatively simple thing. When you do a firmware update on the kit, it upgrades the software as well. So that should take out another failure mode, which is like topside computers. So basically, if your laptop you're working it crashes, you just grab somebody else's laptop or a spare one, and you get access to the software. And you don't have to worry about clashes in operating software. So like I said, we started implementing this in a couple of products. And at some point, some of the products we already have just now will get ported into this kind of software embedded. And it should have an easier access or ease of use for people using it. We did have a reputation for having quite complicated user software. So we're trying to simplify that a lot just to make things a bit more palatable for the end users. The next thing is, if we're taking PPS out of the equation, what do we use instead? And this is where things like NTP and PTP come in. So these are network timing protocols. NTP is the older one. Basically, it's a way of time syncing devices connected to an Ethernet system. We're more focusing on the PTP. So I just grabbed this from Wikipedia, because up until 2 days ago, I had no idea what that was. But upon some research, it turns out that PTP is better. It's more precise. It uses hardware to control the time synchronization on the network. And one of the things it can actually do is measure the latency through devices, which when you're doing survey, when you have to time tag everything really, really tightly, and microseconds become important when you're trying to line up data sets between different devices, and PTP seems to be the way to go. We're probably going to support both, because we don't know what is going to be the main use for the clients. But at the moment, the devices will be supporting NTP and TPT. And that's about as much as I can say about that, apart from reading more on Wikipedia. So some simple examples of how this might look. If we take simple transponder tracking, it's kind of the simplest one we can do. What we've done in this case is the USBL transceiver. We've included the AHRS in there. So it's measuring the roll, pitch, and heading at the point that the transceiver makes its measurement. So we're not putting that onto the network at all, because it's integrated in there. We've got embedded software in there, so all we need is just any laptop on the network will pick up that. We're putting the position and timing from the GNSS on the network as well, and that's just picked up there. And all we're doing is we're just acoustically pinging a transponder on the vehicle. We get a reply, we work out the position. So that's taking away a good half dozen or so serial lines that we would use before. Just makes things a lot easier. Another way you can track transponder is something called responder mode. That's where you plug a cable into the transponder, and you send a trigger pulse from the surface down, and it sends out an acoustic ping. It's picked up. Because we're doing that, we need a good time source. Normally that used to come from the topside equipment, but because we've done away with that, we're now having to rely on time servers, whether it's NTP or PTP. So they get their master time sync from GPS. It's normal, but they're now broadcasting onto the Ethernet. And the gyro, the USBL transceivers, do a trigger generation request. Time server pings that hears that, sends its message. The gyro knows when that thing did its ping, then it'll work out the region of area. And again, that takes away quite a lot of cabling and hassle you would have done in the old way. So again, a little bit more complicated. We're bringing in inertial now into the target we're trying to track. In this case, we've actually plugged the transponder into the inertial device. And that's one of the things, because we build that and we build that, it's easy for us to do. is to support integration, hardware integration into the devices. So again, we're using a time server to generate the master kind of timing sequence. That gets down to the beacon, it transmits. At the same time, the INS knows when it got pinged. And then when it works out the position of the beacon, the USBL system passes the position back down to the INS. So we're constraining the INS drift as well. So that's a kind of fairly simple INS kind of USBL thing. And you can see there, if you look at the line, there's actually not a lot of cables there. And we're not sending huge amounts of data through serial cables. You know, we've got standardized Ethernet telegrams that we're just passing around the vessel. And the equipment just picks off whatever message it needs. Then just going forward, you're adding more equipment in. You need some good quality subsea multiplexer. I don't know who builds them, Stig. And because I'm a corporate man, I've added in some sister company products as well. Just so that if anybody from Cavaria is watching this, I've looked after everybody else. So that's kind of more of a kind of complicated thing, but you can see it's still the same idea. No matter how much equipment we're adding, we've still got a single cable into the multiplex of the vehicle. That just goes up through the umbilical, and everything's just networked together. So it should make things a lot easier to do. And part of the reason we're doing this, the industry's going down a path now where they're talking about interoperability. And that's basically been driven by the Subsea Wireless Group, or SWIG, who are trying to come up with a standard that all subsea communication devices are going to speak the same language. At the moment, they don't. And the easiest way I can explain this is if I built an acoustic device that only spoke English and Kongsberg had theirs that only speaks Norwegian, they wouldn't talk to each other because they don't understand each other. So what SWIG are trying to do is come up with a common language that allows everybody can load that into the equipment and they'll be supported. And it's been going on for several years. I think we're getting closer to where we want to be, but this will be a massive step change in the industry that allows any device to acoustically communicate with any other device, irrespective of where it's made. So they're more advanced with the acoustic interoperability. So it's trying to develop this common standard that's going to standardize the physical data packet and all the different layers that are in the acoustic ping. So Solardyne has offered SWIG to make available 2 of our communication protocols as a starting point. And they're based around just 2 of our 7 telemetry schemes that we use in our products. And what we said is, if SWIG wants to use that, we'll supply all the software development kits, all that to industry that allows them to then encode their messages onto our waveforms. And the reason we've done that is just to try and advance the whole thing, get it going. And also our tech's at TRL level 9. So it's been out there for over 10 years. We know it works. And you know, we'll see how it goes if it gets implemented or not. Free space optical interoperability is a little bit, it's not as far advanced as the acoustic. So that's using light basically to send messages underwater. I think that probably will fall quite soon behind the acoustic stuff. But there's still a lot of things to think about with the interoperability. At the moment, we're looking at that SIS level 3 for Ethernet. I'm basically looking at dynamic host configuration protocols. So at the moment, our products that run off TCP/IP, it's a static IP address are given. A lot of subsea systems now, they're going dynamic. We're not quite there yet with that, but that's where the systems are going. So all this stuff about the next level or the next generation of architecture will have things like DHCP address allocation built into it. But why stop there? Why not go with common connectors and wiring? I mean, the end user would want that. They could take any device from any manufacturer and it's got the same 8-way connector on there. Saves them a lot of money in cables. So if we all agree to a standard, maybe that's something we could, as an industry, we could adopt for subsea equipment. And even go as far as things like API interfaces. That's just some of the things that people, I think, need to consider going forward, where we go with that. I did say to somebody earlier, if we say to industry, there's a common connector that everybody's going to use, there'll be a lot of connector manufacturers revolting. I won't be happy, but I guess at the end of the day, this is driven by the end users and where they want to go. There's a lot of dialogue in the industry needs to happen to discuss how we're going to do this, or even if we're going to do it. But they are valuable discussions to have, I think. So with that acoustic standard, just to give you a little bit of an idea of where we think it's going to work. So basically, it's these acoustic messages, like I said, are effectively text messages. They're encoded onto a waveform that gets sent through the water. At the moment, everybody's got their own waveforms. We've got ours. Kongsberg have theirs. X-Blue have theirs. There's other companies like TNO and who are looking at this as well. They've got their own waveforms. So once the waveform is decided and adopted, then it becomes a relatively simple thing that once everybody agrees on the standard, you basically have a header on your acoustic pane that tells the user this is what's following in the message, and then you've got your telemetry. So that's hopefully going to be implemented sooner rather than later. And I think for the likes of Equinor, who are pushing this quite heavily, the sooner that day comes, the better for them. And that's part of the reason we're doing this. I've kind of gone, well, why are we doing it? And if you think about the case where you've got a racing vehicle in an oil field, and it's going to be flying around there untethered. It's going to be using acoustic communication for long range missions. When it flies close to structures, the idea is that you start using optical control, which is a much higher bandwidth. So you're able to do real-time video on a tetherless vehicle. But in order to make that work, any manufacturer of any optical or acoustic system has to know that their thing's going to work when they plug it in. So setting a standard in that for everybody becomes a lot easier. So it doesn't matter what vehicle comes into the field, it doesn't matter what modem it has on there, it should work with anything else that's in there. That's sort of happening now in some of the fields, but our whole system architecture is now focused on delivering that interoperability in industry, so that we'll be in a position to hopefully just plug in and play and make things easier for the end users with whoever they are, whether it's the vehicle manufacturer or the operator. Just having something there that you don't have to worry about configuration or specialist equipment. It's a 8-pin connector, it plugs in, it works. So that's kind of where we're going in Sonardyne. When we get there, I don't know. There's a lot of work to do. We have a lot of products, but the engineering capability is there for us to do it. And we just want to see where the industry wants us to go and wants our peers to go. And then we'll see what we can do as a collective group of companies and make things easier for the guys offshore. I think that is it. Yes. Any questions? Eric?
What's the challenges? You said that power over the internet can power equipment that takes 25 watts, but to go up to like a higher wattage, what's the challenges there?
We either figure out a way of building products that don't require as much power, which in the case of high-powered acoustics we can't, or we power them locally. Unless power over Ethernet itself, there is standards that can deliver higher wattages. We don't support them yet, but it's something. It's on our engineering roadmap to look at how we get more power from PoE, whether that's adopting one of the other standards like PoE++. But we're kind of limited by physics with acoustics because you have to have X amount of wattage to drive high power acoustics. You have to charge the capacitors in there to deliver enough charge to the transducer to actually send out a 206 decibel ping. So we unless we can figure out a way of doing that based on 25 watts, it's local power sources for the higher stuff, or adopting a higher or a different grade of PoE.
All right. Any more questions, Jens?
One more. Trade-offs between a standardized common acoustic communication protocol and proprietary. Are those insurmountable, or?
The common acoustic protocol, whatever that is a compromise. It'll be limited in how much bits per second you can transmit, and it'll be good enough for what the operators want to do. So if a Sonardyne modem was talking to somebody else's modem, they would kind of live in that common thing, and it would work fine. If it was a Sonardyne modem, we can switch into one of our higher telemetry schemes, which are faster and more robust. And I guess all manufacturers would say the same thing. If it's the same to the same, you can switch into your proprietary modes. You'll get better performance, you get more data going through, you get it going through faster, and you'll have higher bandwidth. But the common one is going to be a kind of compromise that it just allows different devices to talk to each other. So it'll be good enough for day-to-day stuff, but if people want the really high data transfer and more robust data transfer, going with proprietary, like same to same, is probably the best way to do it.
Question. I wonder if anyone else, any other manufacturers offered their telegrams as part of this week group as well? Or was it just Sonardyne?
Up until end of last year, they were trying to develop a brand new waveform. There's a lot of argument over things like what frequency you're doing it at. Some of the military stuff that's out there runs on a lower frequency, which kind of doesn't work. The majority of manufacturers in the kind of in the commercial scale area, we work in a kind of 18 to 36 kilohertz band, just because it's a good trade-off of kind of range versus complexity. The military stuff tends to go much lower, but that won't work in a typical oil field because it starts interfering with other systems. So this is why they try to go to their own kind of like new thing. But we just went, well, why not use something that's established? If everybody else is willing to use that, we'll make part of that IP free for everybody to use. There is, don't get me wrong, it'll take about 2 or 3 years for somebody to take our waveforms and convert that so it can carry their data. But at least it's something that's already 80% of the way there, rather than starting from scratch. But it's really up to the swing group to decide what they want to do. We just made the suggestion that if you want to get there faster, why not use this?
More questions? Okay.
Oh.
Thank you very much, Alan. Okay. Thanks again. I understand you had to fly here for the presentation, so special thanks for that. I'll get this ready. Before I forget, I think I forgot something to say in the beginning. So we'll be taking some photos of the event to put in our social media. If anyone has any concerns about that, just let us know. Okay. Good. Okay, so next presenter we have Sean Elmer. Here will be presented from voice and with the theme of integrated optical survey solutions and edge computing for subsea digitalization. A special title. Looking forward for that. Is up and running. Let me see. Click here on the button, slideshow, and the stage is yours. You want this one as well?
I'll try to just project if everyone, can you hear me in the back? Yeah, very good. Okay, as you mentioned, my name's Sean Elmer. I work for a company called Voyus. Thank you for having me here. A bit of background on myself. Have a background in mechatronics engineering. I've been with Voyus for close to a decade now. So started with the company when we were about 5 people in a small sort of shop. Over the past 10 years, sort of grew the company to around 35 people. There was an acquisition somewhere along the way there. But certainly, you know, when it was just 5 people, I was definitely wearing multiple hats. So yeah, going on site with customer, going in the workshop, building the equipment, trying to really develop the business from that small stage up until the point we're at now. So that's a bit of background on myself. I've sort of segmented my role into only offshore energy, so oil and gas and renewables, and developing that business. Yeah, so the agenda for today, I'll introduce the company a little bit more, explain the evolution of our products, how the latest edge computing has worked its way into these products, and how that all culminates into full integrated solutions. So, brief introduction. Voyus as a company, in a nutshell, we're making optical sensors purpose-built for precision subsea digitalization, and mainly for high-accuracy 3D modeling. That sort of culminates in a few categories of products. First and foremost being underwater laser scanners, using a laser line projector to project a line onto the surface, seeing that line with a camera. That camera is at a bit of an offset, and triangulating points along that laser line in 3 space to produce an XYZ point cloud model. We also have some cameras and lights for really high definition, very crisp imagery subsea while on vehicles that are moving at very fast speeds. We've sort of taken the camera and laser concepts and started to build these pre-packaged payloads for AUVs and for ROVs. A little bit more about our company. We are headquartered in Waterloo, Ontario, Canada. One of the things that we're proud of is we were one of the first dynamic laser scanners on subsea vehicles. So that was the Hugin, which is manufactured by Kongsberg in Norway, for a company called CNC, which is now Oceaneering. So we had our laser package on there back in 2011, and we were just flying over hundreds of kilometers of pipeline and producing 3D models of those underwater assets. And like Alan said, we are part of Covalia Group as well. This acquisition happened 2 or 3 years ago. It's been a really great experience to be part of that acquisition. There's quite a bit of synergy between these companies that are all subsea, many sensor companies owned by the same group. Especially, you know, Sonardyne makes acoustically aided inertial systems to understand where the vehicle is moving subsea. Wavefront makes some side scan type sonars and Voyis comes in with the optical imagery and the lasers, with IVA, a topside navigational software company, amalgamating all these sensors and presenting it to the user in a sort of usable way in real time topside. I threw the slide in there. It's sort of a visual, sort of like a track record of all the things I've been involved with over the years. As I said, I wore multiple hats over the 10 years. So if you see any imagery or examples online and you ask me about them, I could probably tell you who, what, when, why, and where. So yeah, jumping into how our products evolved. We started with these short-range stationary laser scanners. They're rather small. This actuator here, you could probably hold in your hand. We've seen these things installed on work-class ROVs, but held by the manipulator on the ROV. And the whole point of them is to get up close and personal in a stationary manner and rotate that laser head, sweep the laser across the surface, and develop a true scale 3D point cloud. So we've seen these things largely used inside of tubes, creating 360-degree scans to, assess anomalies or inner diameter deviations, that sort of thing. Mooring chains, wellheads, really, as I said, getting up close and personal inside of templates where you might have one flange and another flange a couple meters apart, and you want to try to figure out a spool piece to tie in between those two flanges. So a couple of years later, based on that short-range technology, we had some customers come to us and say, you know what, that's great. Can you do it longer range? And can you do it on a moving vehicle? So not stationary anymore, but utilizing the inertial navigation system with the laser scanner to project a laser line at the surface and fly over seabed and produce a 3D model using all these sensors to create that. So we made this long-range laser scanner. Same concept. You got a laser emitter on one side, projecting a 50-degree laser swath onto the surface. A camera that's been specifically designed to see that laser. And then because of this known offset here, we've calibrated it in such a way that we can triangulate that laser line in 3 space. Yeah, we've seen this being used on AUVs and ROVs for pipeline inspection, full field maps of drill centers, creating essentially a digital twin of your subsea assets. Here it is on Oceaneering's Freedom vehicle. If you look, you might not be able to see on the projector, but it is, you can kind of faintly see a 50-degree laser swath being shot out of that. Yeah, as I said, sort of some of these drill centers doing sort of a lawnmower pattern, back and forth, building up a full wide digital twin of this area. But if you were to kind of zoom in on any one of those field maps, you'd get down to the resolution and accuracy that you see here. And this is only laser-based systems. There's none of our stills cameras involved in this. Again, all collected dynamically. So as the ROV flies from point A to point B, all that data is being streamed topside, presenting a result like this. To give you an idea of a data set of this size, to collect it, probably on the order of 10 to 15 minutes. Flying over the jumper to the manifold here. We've been used for jumper metrology, spool metrology, so tying in a plet or some other structure over to the manifold, figuring out the relative X, Y, Z and yaw pitch roll of those two hubs or flanges, and then allowing the customer to build the spool piece. I've actually worn VR goggles and dove into some of those drill centers, and it's quite different from looking at it at a computer screen. The size of these structures is immense. So moving on from the laser scanners, we started to develop a line of stills cameras and lights. The idea being that, some end clients wanted the stills imagery, and some of our customers were using their own cameras with our laser system. But in order to use their own cameras, they didn't want to see the laser in all their images, so they'd have to inhibit our laser, stop the laser, take a quick picture, and start the laser again. And that all happened in software, but still, as we're flying over a pipeline and you see a gap in the laser data every so often, it's not that pleasing to the eye. So we decided, you know what, we'll take on the camera side of things as well. We have very tight timing on everything, so we're doing up to 50 laser lines a second, collecting those all in real time, and in between the pulses of the laser, we're able to flash the light, expose the camera, collect an image all in time before the next pulse comes. So the software here, that's from our sister company, Innova, as I said, amalgamating all the sensor data. You see our images being collected up there on the very top left, and the data being come in as point cloud data. Here we are. We were used on the Endurance mission, so Shackleton's famous shipwreck under the Antarctic ice. Very much similar package to this, laser scanner and camera installed on a saber-tooth vehicle, 4 kilometers deep in the ocean, and surveying that wreck with both the cameras and the lasers. And then, so we had the cameras, we had the lasers. What we were finding was that customers have all sorts of different vehicles. Even if they had the same vehicle, then another customer, let's say they had some sort of AUV, might be a different rev of the AUV, might be a different year, different model. And it was always such this engineering feat to figure out how to make our systems, first of all, mechanically fit, and second of all, to communicate with their vehicle systems. So we sort of decided to pivot from that idea and try to make modules that directly with the vehicle manufacturers. So we felt like we could definitely reach a broader audience with our sensors if we worked with these vehicle manufacturers. So we have, this is only one example, but this is an Ivor 4 900, which is about a 9-inch hull AUV. So it looks a lot bigger in that image, but they're really small. Has our camera, our laser, our light, and we manufacture this entire section, and it just straps onto the vehicle portion of the AUV, and it effectively gives you the ability to do the laser scanning and the imaging. We are pushing it even smaller. We have the same payload on a 5.8-inch AUV. And the same goes for ROVs. If anyone knows the video array defender, we make a dynamic laser skid on the bottom of that. Again, with everything you need to go do a dynamic laser inspection. It also includes Sonardyne's, our sister company's Sprint Nav Mini. So that's the inertial system that's required to do the dynamic laser scan. You'll notice a sort of trend here where, 5 years ago, we were on these large work class ROVs, pushing that technology into smaller and smaller packages without sacrificing much of the specification. We're finding a general shift in, especially the renewables industry, to start using smaller and smaller vehicles to cut costs offshore. So pretty incredible what we've been able to push into smaller and smaller packages for these vehicles. I should also briefly mention we still make this work class dynamic scanning skid. It is a collaboration between us, Sonardyne, Innova, and Innova. Innova really designed and manufactured the frame of it. There's also an Innova MUX on there, so all the sensors within that skid, everything you would need to dynamic laser scan goes into the Matrix MUX from Innova, and then it's just a simple one cable connection to the vehicle. So this is sort of where edge computing comes in. And I'll give you my sort of very basic definition of edge computing, but it's basically placing the computation as close to the edge where data is being created and where actions are being taken. This largely stems out of sort of the industrial industry, where you may have a sensor that's close to an actuation, and that sensor data is being sent to some server or some cloud place and being processed, and decisions are being made and sent back to the actuator. So the idea is, if we can get that computation, that processing on the sensor itself, right next to where the work is being done, then you can avoid that whole step of sending that information elsewhere. So traditionally, we've always had some form of edge computing on our products. A lot of the times with our old products, it would sort of culminate in this single board computer, which is basically just like a PC in a bottle, where we would send our images from our laser scanner and from our camera, do some processing and spit out a laser stream or process images. Those would go topside to be saved, to be looked at afterwards. They could be streamed to a computer running IVA, so you could see the result of the survey in real time. Or they could be fed to the vehicle to do, automated pipeline tracking, auto docking into Subsea resident spaces. So that's sort of how we did it in the past. Now, where everything is sort of going is using these advanced embedded computer boards. So anyone who's into robotics will kind of know about these, but something like the NVIDIA Jetson, which is very graphics processing based, but it's a small little board that has a GPU, a CPU, memory, power management, and sometimes these are as small as a credit card. So where in the past we had this big bottle with a single board computer, now we're able to accomplish the same thing on a credit card sized board. That's very beneficial in a lot of ways, especially as we're pushing into these smaller vehicles. They're really great for machine learning sorts of things. So we have our sister company who does some machine learning on board some of our vehicles, and they'll say they'll do some eventing on the AUV and say, hey, I saw an anomaly, change your flight path and come back around and scan that again. Or tracking a pipeline and staying on top of it, that sort of thing. It also has consolidated some of our Subsea bottles as well. So no longer needing that single board computer. All of our cameras now have the processor in the back of the bottle. So it's really a single bottle feeding some lights and also connecting directly to the vehicle. So what sort of things are we doing on this embedded computer? Image correction. Kind of tough to see with the projector here, but our raw images, that's what would come directly off one of our cameras. Right on that board, we're doing an undistort and a debayer, so colorization. And then a true color, advanced colorization and light leveling. So when I say true color, what we're doing is using a machine learning technique to really remove the blue and green natural hues that you typically see in subsea imaging, and trying to show the images as if there was no water at all. So, or if you were to bring the object up above the water. These 4 images on the left here were captured by a Remus 300 at 3 knot speed and 3 meters altitude. So it just speaks to the sensitivity of the cameras that we're making. The power of the lights really enables us to create a nice crisp image, even at these fast speeds without image blur. And those images are what was directly pulled off of the AUV and opened up right away. That's what the user saw. So it's really about bringing that edge computing down next to the sensor. Yeah, I guess because of the way that we're doing this computing, the moment that you pull those images off board, they really lend themselves to stuff like this, where it's a very consistent mosaic where you can't see where one image begins and the other ends. Really great for something like a pipeline where you have maybe some 3D data from a multi-beam or a laser, and then you can drape this mosaic over top of that to get more detail out of the asset. Also really lends itself to photogrammetry, so creating 3D models not from laser data but directly from the images. Because of the consistency in the imaging and the lighting, and the way we process those images, sort of mimicking how a camera would work in air, it works really well with some off-the-shelf software. So you just throw the images in and it'll spit out a nice 3D model. So that's sort of the survey side of laser and stills imaging. But where this has all sort of been going over the past couple of years is we've realized that with this edge computing technology, we should be pushing more into the video market. So we have what we're calling Video Plus, which is it does video and stills and 3D modeling all in one small unit. And we really asked ourselves, why isn't every underwater vehicle outfitted with a vision system capable of 3D modeling? There's stock video devices on ROVs all over the place. If you try to throw that video randomly into a photogrammetry software, generally you'll get subpar results just based on the spec of the camera being designed specifically to collect video and not necessarily to 3D model. So this is a small little camera we developed. Again, the Video Array Defender there, if anyone knows that vehicle, it's pretty small. I'm a pretty small guy, but I can lift it up and chuck it in the pool. Yeah, it's small, and you see within this camera bottle here, we do have one of those edge computing devices in it that's capable of doing many things. So the way that we've sort of approached this video is we've done a stills to video approach. So it's actually exposing the camera with its global shutter 30 times a second. Each of those images is going onto that embedded computer board. It's being undistorted, leveled, color processed, the same way that I just showed you. And then being encoded into video, so that the video that you see is actually 30 rapidly processed stills. So it's encoding that, streaming that video up. That video could be used for ROV piloting, for a GVI deliverable. But at the same time, it's also able to save those raw stills to a separate location. So those stills actually contain a lot more information than the video. The video does a bit of compression when it creates itself. So it's important that we actually use the separate stills that we've saved to produce the 3D models. We've taken it a step further. Guess I should have started with this bit of an icebreaker there. Yeah, so we took that monocular V-SLAM type device and made a stereo cam with it, with a lot of the same notions, right? So two cameras taking pictures at exactly the same time with embedded computing within it to produce that video, but also save the stills and tack on top of that, because we know precisely where those two cameras are relative to each other. Every time we take those two images, we can produce a 3D point cloud. So a snapshot 3D point cloud in real time. What you do with those point clouds is you take a point cloud here, you move, you take a point cloud here, and you should be able to map those to each other using V-SLAM techniques to produce a larger point cloud model. Our system doesn't do that merging of the individual point clouds. So we like to sort of be more of an open format. I can explain a little bit why we decided to do that maybe after, but it works great for some of the vehicles that we're on being able to stream that into their vehicle control and have them decide what to do with that data, perhaps for manipulation tasks or developing a model to simulate where the ROV is within that 3 space. There's other softwares like our sister company Innova, who we've sort of partnered with on this, who will take all this data in real time as you're moving around the environment and continuously build up that 3D model, sort of in a sparse 3D model, so not as dense as what you can achieve, but then in post-processing, densifying that result shortly after the survey to produce a point cloud deliverable. So as I mentioned, little embedded computer board inside the unit. All those images are going onto there. They're being processed. You get video, GBI deliverable, raw stills output. You could also save the process stills to a separate location and produce those snapshot point clouds. And that's all happening in real time with better than 120 milliseconds latency. So glass to glass, that's typically 120 milliseconds is sort of the sweet spot that ROV pilots would like to see for using the video for piloting. Quick little cell phone video here of, on the right, the video from one of these stereo cameras, and then on the left, those point clouds, 3D models being made quite rapidly. Summarize some of the core advantages of going with this stills to video approach. A lot of it has to do with real-time data. So the low latency for piloting, you got all the goodies of that, the image correction happening on board that camera, crisp stills, high-res video, and onboard point clouds. That all feeds into enabling autonomy within some of these vehicles that don't have tethers, can really make use of that information and decide what the vehicle wants to do. So that's sort of the autonomy side. And then there's, of course, the customers that just want to do 3D modeling. Also that capability as well. And sort of last little bit for me here, integrated solutions. So I mentioned we're part of Covalia Group. So this is what some of our customers are doing with the various bits from the Covalia Group. So we might see on the downward side here having our laser scanner and stills camera for doing pipelines and seabed digital twins. You might see our stereo camera there on front for when they want to do some more vertical inspections. So encircling trees, maybe there's a jacket that's 100 meters deep that you want to go back and forth up and down on and create a 3D model. Of course, you got Sonodyne's Sprint Nav system on there, acoustic positioning system, and then all those sensors going up and feeding Innova's topside software. Another vehicle, up and coming vehicle we're on, so the Nauticus vehicle has the full package from Voyus. As I mentioned, Sabertooth, a couple different customers using this, but notably the Endurance mission using the Sabertooth. Oceaneering's new Freedom vehicle, largely a lot of pipeline following with that vehicle going on. And that's it. Hopefully it wasn't too much.
Any questions? Elizabeth?
On the dynamic laser scan slide, it got my attention because it said school morphology. My question is, do you have any track record of this? And if you do, maybe it's the second two-fold question. If you do, have you got any proof or any distances for this? Or like we call it the NOSP veritas here, but I don't know if it's Canada. Yeah. Sorry.
Yeah, so we have one main project we did a couple of years ago in West Africa, where there was several, I want to say close to 20 drill centers that we did. Each of those drill centers had a couple metrologies that needed to happen, so they very much used that data to produce the spools and jumpers. We've done a couple comparisons to more traditional methods out in the Gulf, where we would fly over a 20-meter baseline. It is a rather rapid data collection approach, so to go 20 meters hub to hub, you're talking a couple minutes there, a couple minutes back. So you can actually spend the time to go there, back, get 4 runs and take the measurements individually amongst those 4 runs. If any of those are off from each other, it's an anomalous survey run and you can throw it out. So we've done trials there.
Did you say that was 20 meters that the drone actually went up to?
There's been some 30 meters as well, but as it goes with metrologies, sort of the further away those pieces are, the more lenience you have. Yeah. So yeah, and I would say the limitation of the laser scanner is very much on, sorry to say this, Alan, but the accuracy of the inertial system and the acoustic along baseline solution as well. But they've been using acoustic stabbing technique for metrologies for years, so this just sort of taps into that and adds another layer to it.
Can I just expand a little bit on this? If you go from A to B and back to A, and don't both process and they rotate and then over deviation, you haven't get that much.
You would expect them to be exactly right on. Yeah, it's actually an interesting question where there's always going to be a bit of drift.
Yep.
It's tough to say exactly how much, just based on a simple question. We do have some laser-based loop closure algorithms that we've developed. So, for instance, that endurance shipwreck, we didn't have any LBL, we didn't have any USBL. We just had an INS on the vehicle, and we found over the course of that 4-hour survey, the shipwreck drifted lengths of the shipwreck, so 20 meters from when we started to where we finished. But using these laser loop closure techniques, almost in the click of a button, we're able to suck it all up and tighten it up to one consistent model. So I'm hoping to see a little bit more of that laser-based loop closure applied to the oil and gas sector.
Is it a pre-calibrated system?
Yeah. So you saw with the laser scanner, it had an arm connecting the camera and the laser. So that's all calibrated in-house in Canada. The one thing that you need to do if you were to take the laser scanner and throw it onto a vehicle that already had an inertial system on it, you need to understand where the laser is relative to your frame of reference on the vehicle. So we accomplished that through hand measuring and then following up with a patch test to kind of fine tune the levers.
Right. This one, yeah. Okay. Yeah, special thanks to Sean. Had to fly all the way through Canada for this presentation. So hopefully you have some orders in your email on your way back. It's all worth it. So we will have now a 30 minutes pause. There is some still nice food there back there, I think. If you are online, you just wait 30 minutes if you are live. If you are not live, then you can just drag 30 minutes further and then you see the rest.
I don't.
All the competitors.
Nothing. That's only the. There is pure PE.
Okay. Hope you enjoyed the break. We have now Stephen Foss from Fostech presenting world-class subsea solutions. Welcome, Stephen. And would you like a microphone? Or...
I'll try without this. Do you hear me, everybody? Okay.
All right.
Yeah.
So stand here with the camera.
Yeah. Okay. Good evening, everybody. I had the pleasure to talk with some of the students in the break, and I heard that some of them already had got the jobs before I did education, so that's good to hear. And I guess seeing so much smart young people is good, meaning that you are doing the green transition in this in the subsea world. So I think that's good, really good to see. And I think combining the youngsters with a lot of seniors, including myself, will be good. So my name is Stephen Foss. That's why the company is called Fostech. So I have a bachelor in mechanics, and I also, when I found out that I'm starting my own company, it would be good to understand some figures. So I took also some economic education, and I think that was wise. Okay. Here you see our factory overview. We are situated in Sandefjord, 100 kilometers south of Oslo, and that is the sunny part of Norway. And well, I say no more. So here you see our site. We have 4,300 square meters at an industry area close to Sandefjord Torp Airport. It's a good place to be, close to E18 and also to the airport, easy to come to Stavanger. So that's good for us. Our departments in Fostech, we have an engineering department down here. Multiple disciplines within electro, automation, mechanical, material. So we can do quite a lot of complex projects for ourselves, doing our own products, or for our good customers. We do a lot of R&D work. We have PhDs within material technology, especially polymers. In 2014, we had a really crack with the oil crisis, and we lost about 30% of our turnover. And we understood that we had to do something smart. and really quick. So luckily, we had good cooperation with our most important customer, that's Kongsberg Maritime. And the head of the CEO is down there, Tore. Hi, Tore. Good to see you. So we had we did an innovation project with Kongsberg, and the main topics was encapsulation of electronics. So that's brought us really good today. So that was a wise decision, and decision, and well, I'm glad we do that. We have all type of disciplines in Fostech. We can do everything ourselves, and I think that's good. For sure, we use sub-supplies, but that's to on top of our own disciplines. We have a machine shop to do prototyping, also some production. We have a cable manufacturing department, soldering, crimping. We are good at 3D printing. We do mostly polymers. And we also have an electromechanical department for building consoles. Recently, we have set up a new facility for building seismic underwater seabed nodes for one of our important customers. We assemble the batteries, weld the batteries, solder the electronics, and then we mold everything in solid polyurethane. So we're producing this year. We're producing 3,000-4,000 of those. So it's really good, and we're now planning for robotizing the production line. And I think you can say what you will about the COVID situation, but what we feel is that Norwegian industry has really very much is brought back from Asia to Norway and Europe. So that's good for us that loves industry. Yes, our markets. Fostech was established 25 years ago. By me, I remember the first day at the office, and I looked at the phone. I was on me, and I was waiting for the phone to call. Where are the customers? And well, I guess that already after lunch, I understand that I have to go out and find the customers. But it was only 1 month that I was alone. So the business idea of Fostech was in the start was I'm a mechanical engineer, so it was mechanical engineering, and also have a small workshop to bring prototyping fast to our bigger customers that aren't so fast as us, like Kongsberg, not very fast. So that's good for small companies like you, us. We have had a good increase in our turnover the last 2-3 years. 30% increase from 21 to 22, and another increase this year. So the budget this year is 160 million NOK. And number of employees, this slide was from yesterday, then we were 70, but today we are 73. So that's good. You see our markets here. The last 2 days have been in Stavanger on the modification conference at Sola. Really good to get an overview of the projects out in the North Sea. And well, it's really good times, especially for you youngsters. So you have a bright future. Energy is still important for us, both within Kongsberg Maritime, but also within the seismic business. Maritime business, for sure. We have a couple of own products within the maritime business. Defense, sorry to say, but that's really an active branch these days. We work within naval defense, and last year we got our biggest contract ever. Norway is buying 4 new submarines, Germany is buying 2. They're built in Germany. And we won the contract with Kongsberg Defence for the combat system, the consoles for the combat system. So we're doing the engineering, all calculations for strength, test, vibration, shock, everything. And it's really good for us. And the reason we won was that we had the good components within engineering, and also that we had both engineering and production on the same roof. So that was so now Fostec is in the Champions League. So that's really good. So our order backlog now is over 100 million NOK. So that's good for me, and it's good for our employees. Energy transition within different markets. We come from the subsea market, but it's a bit funny. We got a telephone from infrastructure, the Statens Vegvesen here in Norway, and they had trouble on the E6 close to Gardermoen, Oslo Airport. They had a project there with putting LED lights on the road, about a meter over the road, and they typically is buying something cheap from China or something. They worked 3 months, and then they had to call Fostec. We have a problem. So, but we used a year to being able to mold in LED lights. It's quite difficult because you kill the LEDs with the gassing and everything. So we've delivered a couple of thousand LED lights, and they're subsea quality. You can throw it in the water, you can drive over them, and they cost 1 krona less than the ones that were there. So this is a funny history. We have also some products within fishery and ocean farming. So that's it's good to be subsea, go up and down, defense really stable right now. But I think it's important for Fostec to work within different markets. You are a bit more robust that way. Here is our customers. So without Kongsberg is present here today, I know Subsea 7 is here, that acquired for Subsea. We do a lot of sensor work for Subsea. Autronica is based here in Stavanger. We deliver fire detection systems for them, building consoles, racks, everything. I don't know if you've seen the Norwegian film Nordsjøen. Have you seen that? Have you seen Illum, the snake? We do a lot of work on Illum, so that's quite interesting product. And Kongsberg have the majority of the shares there, and I think they're coming stronger in now because of the autonomy technology. Yeah, a lot of what we do is cable work, doing thing watertight, down to 6,000 meters depth. This yellow one, the yellow hose here is our own product. It's an oil-filled compensated cable. All the mechanical stuff here is in titanium, so it's qualified down to 6,000 meters. Molding of electronics is one of our main topics. We use often polyurethane, but you have about 1,000 different polyurethane types, so you have to choose what to use for each product. Building electromechanical racks is really important, both for Kongsberg Maritime and also for Autronica here in Stavanger. Kongsberg has a very cool product. They are working with another big company in Vestfold called Jotun that you know by painting, and they have a project together that is called Hull Skater, So it's it's a robot that you can send down the ship hull, and it cleans the hull. So it's very good for the environment and getting down the fuel cost. So it's very good. So we're building all the racks and also some R&D stuff, the tether, etc. for that product. Did you know that, Tore? Yeah, you did. Yeah, that's good. Cabinet production, important for us. For the new submarines, we're also building the cabinets. I think a submarine is the most complicated product you can build in the world. It's more complicated than an airplane. So, and I understand why. So it's really bringing us in the top league, working with Kongsberg and Germany in this project. Engineering is really important, and also have a close attention with the 3D printing. We use 3D printing not only for prototyping, but also for production. So it's a really good skill to have inside. A couple of last year, we took over from another customer, service department, doing service for firefighting for ships. And they're big ships, ferries, yachts, and they have to be certified each year. So we have people traveling all over the world, doing service for the Fostech products. It's important that when we do R&D work, that we have facilities to do testing, and we can go to our customers. Okay, this will probably we can guarantee it for 25 years because of the accelerated tests. So that's important from our side. Our own products, we have a product called Omicron. That's really good, and we were first out. This is a sensor for measuring gas levels in LNG tanks. I think Omicron is meaning a small particle, and our sensors going up and down here is what it is. We've talked about the oil fill table, our IP around molding LED lights, our fishery equipment. I have a couple of products there. The firefighting systems. Lately, we have set up a production line for batteries for bigger ships, and batteries is coming more and more. What is special? What we do is that we mold in the batteries in fire-resisting molding mass that you can see, the yellow ones here, and you can put it in water if you want. It has been some fires on ferries with batteries, and this way of doing this is taking care of the security, and you can also cool it with water if you want to. The old batteries for ships, you had to put it in a container, and you had to cool it inside the container. So this look forward to get this into the market. We also do some products for the special forces in Norway. It's equipment more like you see on James Bond films. So what you see here is thrusters that you can put on the diver's legs, and we have a battery package on the back, and you can drive underwater with this. So this is really cool. So our engineers have been out in the sea all summer doing testing. So it's a really cool product. We're also having a product for the same users, and that's warm threads that are in the diver seat. Because when you use this propulsion system, you don't use your body and you get cold, and so you have to compensate again with a diver suit with heat. So that's also for the same customers. So I guess this is my colleague Christian. We are often out on the road trying to sell Fostech products, and I think we've succeeded quite well. So I would say thank you for having me here this late evening, and it's always good to be coming to Stavanger with the raincoat and everything, but the people are really hospitable. So thank you, everybody.
Okay, thank you, Stephen. Any questions?
I guess it was quite clear.
We've got a lot of young people here, Stephen.
Yeah.
What advice would you give to them if they wanted to start their own business?
Okay, don't think too much. Just do it. I think networking is important. Doing networking. I think that's when the phone didn't call, you have to use your network, and it's not easy when you come out to the school, but maybe your colleague in your class, and you know the people. Keep networking and joining in this type of arrangement is very wise. I think you're meeting people, doing connections. So I think that's my best advice. I think so.
Very interesting.
Yeah. Thank you.
Okay. Thanks again. Okay, that was Stephen Foss from Fostech. I'm not going to use the microphone as now is Terje Olstad from in-house Innova. Terje?
Thank you.
Oh, let me just put this for you, please.
That would be good. I can compute more types of computer in a way that nobody can predict. So when they send in new network people, they give them 2 weeks warning with me first to get used to a few things.
All right.
This should be
You
possible.
go.
Yeah.
Okay.
Am I in the correct angle on the camera and everything now?
Let me see. Smile. There you go.
Smile. I can't promise that all the time. So thank you, Ricardo, and thank you also for 3 very interesting presentations before me. I think I've done 4 parts. So a little bit about Innova in general, a little bit similar to what Stephen did before. And then there will be a 3-part thing concerning Moxus. Quite in general, we will touch a little bit into what we are doing, but I try to keep this quite general. And there will be similarities to what both Alan and also Sean has been touching into. So it will be some history where we are today, and also then possibilities for the future. And they are surprisingly overlapping to what Alan said. We didn't conclude a lot before he came here this morning, and obviously we don't agree on everything, but I think we're fairly much in line, actually. So we can start out a little bit in Innova. Here is a lot of similarities with the previous presentation. We started in 1997. We have been nominated to the Entrepreneur of the Year, and we have been up to around 75 employees. I think we were down to 45, 50. We are on our way up again, and we have had quite similar turnover numbers. And I think we might have been a little bit clever to standardizing a little bit more of what you're doing, because we are terribly prototypical all the way. And that is a very interesting place to work, but sometimes it takes a little bit more energy than you would believe, and you know a little bit about that also. We are in general supplier of equipment and services to the international underwater industry. We do a little bit of stuff that's not only underwater downhole, and we do some bits and pieces above the waterline, but I would say 96% until now is from sea surface to the seabed. And that we're trying to summarize this in short sentences. It's not really practical, so they could never be totally covering, but ROV is a keyword. Many of us comes basically from oceaneering, Subsea 7 and so, and at some stages we have had up to 25 previous oceaneering employees in the building. Some say that's good, and I think it was a very great place to work. I spent 6 years there, then 1 year with McCartney, and then I've been here since the beginning. 2 very good colleagues from the start, and also many other people. It's a multidiscipline engineering and development team. I don't have the exact headcount at the moment, but we have had people of every conceivable engineering background, I think, possibly except chemistry, on bachelor level, master level, and PhD level. and with a core in mechanical, electronics, and software disciplines, but also mechatronics. Obviously, we have had several people here working on the naval strike missile, 2 or 3 of those from Kongsberg. Very good place, very good education environment. And we like to promote ourselves both to the customers and also to possible employees as a high technology multidiscipline environment. And also the statement, large enough to deliver, small enough to act. We have a quite strong network of sub-suppliers also on engineering disciplines that have enabled us to do some really interesting projects. And we also have very good cooperation with companies like Sonardyne that we are working very closely with, both on the product side and also on developments and our aims to try to standardize what we are doing. That gives quite also a pointer in here. Is it live, or I need to see if we can do that without ruining anything? So there, it is on this screen, but no, here it is. Right, there you go. Control electronics, mostly for pressurized environments. We don't pot things as much as you do. We are very much putting it in oil to be able to, and this board, I think, is one of the first things we did. And that's just an example. I think we are now on a new version, which is really doing the same thing, just including more Ethernet again, which we'll come back to. I think this is sold in close to 1,500 examples. And it's sitting worldwide in equipment, all from Scanmøring's excavators, all of Frank Moen's oil skimmers, and a magnitude of kit that you really wouldn't imagine. But the core is really oil and gas related remote tooling and ROVs of any kind. So it's a proportional valve controller and then a set of I/O running on a serial line. Camera and video systems, we don't make them ourselves. We sell them on behalf of others. Hydraulic valve packs. That is almost entirely built in-house, buying valves, making everything else. Fiber optic system, we'll come back to that in more detail. We have a good cooperation with Forum as the rep on ROVs, also selling their thrusters, the previous sub-Atlantic range. Subsea connectors, cables, Subsea HPUs, that is a very wide range from ROV type of HPUs, high voltage, high power, with up to 400 kilowatts per unit, down to 12, 15, and also more permanent style HPUs that I think we have one unit sitting somewhere out here, that we also ran the world's first subsea hydrogen, oxygen, and fuel cell as a completely autonomous exercise 1.5 years ago. It received also quite a lot of international press. Again, we should ask ourselves, did we make money on that? Of course not, but we hope someone will catch the really coolness of this thing and finally go and buy it. So navigation positioning, that again, a lot related to what Alan and his colleagues are doing. And in addition to that, you can go on for a very long time. You can show it to the camera also. I think I don't know more than 1 or 2 more people in Norway that have a manganese nodule in their office. And we have been in 3 or 4 quite large international subsea mining projects, doing everything from fiber optics to hydraulics and key components to get things working. And we could go on more than that. I got 5 minutes more potentially without ruining schedule. Okay, I'll try to keep online. Mission statement, integrate innovative solutions for harsh environment. So again, that's mainly underwater, but also going downhole more. I think you also mentioned your work with ThyssenKrupp. I think are part of the same contract. We are not delivering to the submarines, but to other prototyping projects. So we are working on a quite big contract for us now that's going to be delivered in the autumn. And as you see, we are mainly coming from the oil and gas background, but we have been working on both defense, ocean science, and agriculture all the way since the beginning. After the oil crash in 14, 15, we had up to 40-50% for many years, but that is related to non-oil and gas. Obviously, that also includes wind farms, which was the main market, I think, for Maxus from 2016 through to approximately 20. You can see Merck, which again is aquaculture. We have a lot of projects, some very small, and this one really large, concerning salmon, sea lice detection, and devices to counter that problem. I think you also have Stingray on your list. I think it's in the same list. Obviously, we also deal a lot with Oceanary. They're somewhat a competitor. They're also a big customer, and we are also buying quite a lot of businesses from them. And all the major rental companies in the world is really all quite big customers. and I can try to jump on. So now we are on next section. Why do we need the MOX? I have a risk of going really technical later on, but then I go to do my disclaimer in the same format as Alan did. Just rewrite it a little bit. He obviously knows much more than he will admit, and I will just rewrite it. Yes, for engineering. And I basically had a bachelor in telecoms, and then I tried to do my master's in my spare time working for engineering, which didn't do really fantastic ratio and never get the big PhD sponsor on that, but I concluded it. And I also worked really in all departments. They're employed by the engineering department, building everything from electric torque control system, but also working as an ROV pilot and a surveyor, which I guess you can assume this will end up in an insane amount of overtime, and that's true. So I don't really know any single subject very well, but I know a little bit about very many things, and that is what I'm trying to survive on these days. So the MOX is the expansion of interface capability for an ROV or ROV towed vehicle, and any other tooling or system, but that's really the two main tasks. An ROV in itself, with a few exceptions, can be seen as a kind of tractor, and you can put it out on a farm and you don't really get a lot of stuff done before you are able to add things to it. And traditionally you could put 2 or 3 or 4 things on it, either hydraulically or electronically, and then you will run out of places to plug it in. And then the purpose of this thing is to just to do a more or less sophisticated expansion box to put things together, to run it to the surface. It will be needed to run data from the sensors upwards, uplink, send control signals to sensors, and also to maintain a control the time of everything you do. Of course, there's not the same latency on any type of sensor. Some things need to be post-processed. You need to know where all the data originate from, not only geographically, but also in time. History. And this was surprisingly difficult. If you go and search and try to find pictures of stuff that's more than 20 years old, it's virtually impossible. I had to pester a couple of my colleagues trying to find something that was at least somewhat relevant. The top one, Phantom, I think is one of the vehicles we used to sell in our engineering. It's actually not multiplex at all. It's completely hardwired. From the surface, you have certain 2 or 3 wires to every motor. You have direct coaxes to all the cameras. You have hard wires to every single sensors, and that obviously ends up a very thick cable. You can't dive really deep with it due to the drag on the cable, but it's a very simplistic things to maintain. You can't dive very much with it. Then you're moving across more to Subsea Dolphins ROVs. It's more the traditional late 80s, early 90s. I think everything is still running on copper. No fibers involved yet, but we are in the transition time for that. You all still need somewhere to plug things in, but we haven't really done anything more than some really complicated electronic MOXes, analog stuff, moving analog video to stack them in various frequencies on just like a broadcast type of video system, which ends up with an immense amount of boxes and things and big canisters. The largest system I know of from the late 90s was Comex was building a series of vehicles. I think they made potentially 3 in the end. There was a dedicated survey vehicle, and we built the canister for it, I think very late 90s. And the total capacity we thought pretty insane at the moment was 3 gigabits, which is now less than you get of 1 SFP, really, these days. But that could cover all future needs stated at the time being, and I think it did for a very long time. We also built some custom MOXes early on, 98, 99, 2000, for what used to be GeoConsult, became DOF, and we had to relate to a very interesting mix of plus minus 75 volts, 24 for as you mentioned some of the same table, and I think you covered quite a few of them, but it's only the fantasy that can limit people building equipment if you don't enforce any kind of standard on it. Everything started out in copper, but we started seeing fiber-based units. In the early 90s, also Saga Petroleum in Norway was the first, when they wanted to install an ROV on the Snorre platform, to actually enforce all the regulations in the cable, stating that you are not allowed to run high voltage in the same cable as twisted pairs and coaxes. It's obviously a safety reason. If you cut the cable, you can get that high voltage into the console. There's some devices to minimize the effects of that, but they actually enforced it. So we had to rebuild massively a system to fit into a single voltage umbilical that did not exist in the industry in 1992. And that has been a part of the transition to fiber equally as much as the need for more data. We're still running analog video, coax, multiplexing equation done use of, I call this frequency stacking, but I don't know if that's the word. Somebody told me it's not, but they didn't offer me a replacement. So do you understand what I mean by this? Your baseband video is like 5-6 megahertz from 0 and up. It's what you get when you run standard monitor if you don't have any receiver involved. In the old days, you have to go and tweak the channels on your TV in the UHF and VHF band. Then you were changing the frequency you were looking for. And we built systems when I were in Oceaneering to use a similar system to run many cameras on one coax, because that was the only thing that was left. More history, and this surprised me a bit. I tried to find out where all these standards come from. When I went to Ørlandhaug, where you guys are from, it was RS-232, RS-45, and I don't think they mentioned Ethernet. It was actually existing at the time, 1993. RV system over at the Dolphins RV from around 1992, and it still don't have any Ethernet bits and pieces in it at all. Ivan Brems, one of my colleagues, he used to work there for many years, and he said that is still copper-based, and so on. The specs are actually quite old, as we can see later on. The specs we are looking for that Alan also mentioned are close to 15 years old. Some of the bits and pieces we need, some are 5, but they are been around for a while. And we are not possibly not the last industry in the world to adapt these things, but we are certainly not the first. We are not a consumer gaming environment, but I think we are on equal footing with perhaps aircraft industry, medical, and so on. But the speed that we are able to use the standards existing may be improved a little bit, but that needs to be a joint industry thing. We have latency there. Some of the equipment built utilizing really old style stuff is built 5 or 10 years after the appropriate standard actually existed. One of the examples is PECL, positive emitter coupled logic, was introduced by Kongsberg and Raison approximately at the same time when they started building multi-beam sonars that needs more than 100 megabits. But it was still many years after the gigabit standard existed. But there was no hardware available, and you couldn't really count on the ROV to be able to transfer it. So, and also the technical lifetime for much of this equipment is typically 10 years. So we delivered PECL as a standard option on our Muxus until approximately 3 or 4 years ago. Of course, it went out of production 13 or 14 years ago, and we had to support it for 10 years after that. HDSCI, high definition video for transmission without latency. I saw you had glass to glass of 120 milliseconds, but was that with the H.264 or something?
The conversion to H.264 on the board.
Yeah,
and then
that's really that's rapid. Yeah. That's
Yes.
impressive. Of course, we haven't been doing that, but we have other companies around that. At least a few years back, that was on 160, 180, 200, and so on. And the pilots don't like that when you drive and you stop and things happen after you stopped. Of course, there is a 0.2 second at least on one way, and then you get the feeling something is not right, and you can mess it up for yourself. Moving to present. Majority of RVs still do not have a lot of capacity. 1 or 2 exceptions. There might be more of them, but we know of these quite big vehicles made by Kystdesign. I think they made 2 or 3 of them. I guess you might be using them in some contexts. I don't know. No? Yeah. Have you seen them in use? Yeah. And I think the first customer was an MMT. Yeah. And then I think that was made to be able to run 8 knots. When I talked with some of the people using it initially, and they were scared to death when running at 8 knots really close to the seabed. So I don't think, but I think one of the first jobs they did was a survey from Iceland to Scotland. And I think they did in 3 times less time, vessel days, than they usually have. But it's a very specific thing. You can't use it for anything else. It's expensive. And it's based on the same electronics as this all the way through. It's the same fiber optic board or the full package. So we're involved in that one. PCL has been replaced by gigabit Ethernet for multi-beam sonars, and you're also utilizing gigabit Ethernet. That's what you need. IP-based video becoming accepted, giving still some latency. You gave us a very good number of that now, and no people are accepting it for everything except for the navigation camera for the RV pilot. They still prefer to have something direct. And on our big muxes, I think it's still a standard with 3 times HD SDI, but that's a raw data format. And that is depending on how much you scan it. Is it 1.2 or 2.5 gigabit per second per channel, which is a very hungry thing to run through to use bandwidth on. And that is still in use, but several of our key customers keep telling us that obviously we are upgrading all our electronics these days, but we might not need to make a new HDSDI board due to the effects that you have also been mentioning there. ArcNet has fallen out. I didn't say a lot about it. It was the core of some sonar systems earlier on that just went one step past the serial lines. Tritech used it, Oceaneering used it on ROV control systems. Early 90s, and that was hanging on for quite a long while, but that has disappeared totally. Serial lines, which we could see earlier on, was basically starting out as the first specs in the 1960s, was predicted by some really major players in the industry to go away very soon. And that was like 3-4 years ago, and they said maximum 2 years. But there's still a lot of smaller bits and pieces, and you can see some of them out there on the what you call the workshop, and then they are still only delivered with serial outputs. So we're somewhat caught in there, and there's a way still to go. So that has not gone away. PPS, the pulse is still there, usually TTL signal, because Ethernet is in its nature not deterministic on time. It has been a key selling point for us, both on our electronics and for boxes, that we know within the microsecond when things are going to happen on the other end, as long as we don't introduce any packet switching or something. On any channel, it's depending on type, it's either 6 or 7.4 microseconds, whatever it is, plus the propagation time. And that's the same every time you run it. If that is increasing, but not yet for timing and for power transfer. And then we are approaching what Alan also did. Is that always used for uplink on multi-beams and attitude heading reference systems? Similar. Downlink can sometimes be Ethernet, and sometimes it requires serial, depending on what manufacturer is involved. But the PPS, I think, is still exclusively used for anything related to timing. Current MUX manufacturers, obviously, I made a little bit larger pictures of, didn't want to hide our competitors, they are still there. So this is McCartney's Nexus, which you occasionally see. They also own a company in the States making very, very small MUXes, EMO. And obviously we also have our friends up in Haugesund, or Ham, who do the RTS MUXes. And we are seeing what we have seen as our main strongholds has been really on the diagnostics and power distribution system. Everyone running a solid case on the signals. But when some of these others started to make serial production, which we are again very slow to do. We love building prototypes with an enormous amount of consumption of hours, and everybody can get exactly what they want, but never make money on it. So they are much more clever in standardizing something. But I think we built 10 or 20 MUXes completely different before we finally forced ourselves to build the Mark 1, which solved absolutely everything, cost the double of everyone else, and we sold 2. It's enormously large. And okay, this is what you asked for. No. So we built then the Mark II, which was then solving 92 or 94% of the problems, which is more than enough for most of our customers. Much smaller, it's half price, and then we're really in a good range. And then I think we ran into something similar that someone else mentioned. We did a Mark II Plus, and we can use some of the same reasoning behind it. We did upgrades that are not, for most cases, visible. It's more better on EMC. Is better on mechanical vibration, the whole kabang, and also quite upgrade the surface unit, but the interfaces are essentially much for the user side. I think you can use almost all the cables straight in without changing anything, which also is a key point. I think most of has now been upgraded to 1200 watts, and we also have seen that I think everybody has been picking up on the way to troubleshoot. You showed impressive amount of cables, but it can actually be at least as worse as your worst images. I have been in quite a few of these consoles, and it can be bad enough in the console and the surface, but when you go subsea with all these cables and you get the fault and you dip it and you get the ground fault and you have 20 or 30 or 40 cables in there, you pull it on deck, and the fault goes away. And the only way forward from there, unless you have someone to guide you where this arrow is to disconnect half of it, dip it again, and see if it disappears. And then you can continue in half and half. And I've been on a couple of these exercises in the early 90s, and nobody is happy because this is on vessel and potentially rig time. So if you can build a solution where you, by turning on and off the outlets, can see, I turned off number 16, the ground fault went away. You can have saved 1, 2, 3 days of some angry people, as you say, screaming down your neck and so on. It doesn't really help you. But that was one of the things we brought along from these 1621st designs. And we have had full multi-pole disconnect and ground fault on detection of everything, leaving the canister as far as this physically possible. You can't do it on HDSDI, it's not physically possible to disconnect, but everything else in there is as much as we can. We have insulated power supply for every serial line. They are galvanically isolated. We have DC-DC converter for each channel. We are increasing the number of channels on Ethernet that's coming along. But, and then we are touching again to that. You recognize these. And nobody is expecting anything else. When you plug something into a PC, there should be one of these available. When I'm giving this pin with a presentation, you will find multiple of these. When you're looking for a connection in the wall, you will find an RJ45. And the situation on anything subsea is not remotely there yet. And I think we have not been so clever, and I think I have been blaming Sonodyne for being the largest user of different types of connectors. And it's same engineering enthusiasm running there as we have. Everybody should have it exactly the way they want it, but that ends up with nothing being able to plug into anything else except to make a very dedicated cable. And this is the best discussion we have in big rental companies. Most of them have now passed a pool of cabling worth more than £1 million. They are getting to 2, and they have dedicated people trying to keep track of the types and the qualities and the wirings and everything. And it could potentially be cut down to a third or something, if we can just get down to 2 or 3 types, ideally.
You're good.
I think I'm good so far. Regarding timing, I think Alan touched into this. We have mentioned this. When you go through a switch, there's no demand from the basic Ethernet specification for a specific time for this to happen. So as long as you run a gigabit channel, it's usually a point-to-point thing that we just convert light to electricity and back and so on. It doesn't affect the timing. As soon as you run into anything with the switch, you need to have a switch that is prepared to keep track of the time in a deterministic way. For most relevant devices, the channel running down is usually a gigabit channel on the optical side of it. So you end up with a gigabit each side. So you need to do something to achieve a high number of 100 megabit channel, which is what most people need, except for the lasers and for the multi-beams. So there's relatively few users that need that raw style Ethernet. Then you need to put in a switch that could, as he has been mentioning, Alan, network time protocol, but as far as we can see, that is offering synchronization down to 100 milliseconds. And if we have understood this correct, that is not really within, if that is the best you can do in that environment, it will not help us, because 1 millisecond of propagation time of sound in water is probably 1.5 meters, 1.48 or whatever. So if you're 1 millisecond out, you could be 1.5 meters out. And so 100 millisecond is not, if that is true. So we have been assuming that the PTP, which is in the newest version, I think you also refer to it, that is guaranteeing less than a microsecond. And if you build it in the correct way, you can go to nanoseconds. So that is the timing side of it. And I think somebody asked for more than 25 watts. I got the complete table in there. You have been aiming, covering your devices, the PoE plus. There is a PoE plus plus, and another PoE plus, which is 51 and 71. But there are some issues also related to this. You can look up again. I didn't cut the complete thing from Wikipedia, but I've done something similar again here. But there's a lot more detailing. There's a mode A and there's a mode B concerning the wiring that we also need to address in common in some fashion. and some of them also then on at least the type 4 exceeds 50 volts on the pairs, and then you're into, at least in Europe, a legally different mindset to how you can handle this with male pins with voltage on and so on. So, but all these standards, the last of these I think popped up in 2018, so they're quite new relatively to the other ones, and the ones you really need for most of the stuff will cover up to 25 watts, but it's possible to build up to here. Yeah, I've been through that. And connectors. You could run, as previously mentioned, a quite simple 8-pin would cover at least up to that 25 watt without any issues. You can also run these up to the 71 watts, but the smaller, cheaper connectors don't like more than 100 megabit. So you can't get through more than that. Is typically a subcon is also offered by a couple of other contractors. It's a thing that is available from more than one supplier. If you run up to the one we use for all the own MUX, that is basically a Burton, also made by Seacon, Glen Air, and different, is also available from at least 3 suppliers. And we should aim for something that I guess is available from multiple companies. And also, if you want more than 71 watts, we would like to take these same boards, same boxes, same MUXes also to run tooling skids, work packages, everything else. It doesn't require that much more, but then you would need to run pins on external power on more pins than the 8 provided by the POE. And Scorpion has started to make such connectors. Glen Air has designed such a connector, and they have also, Scorpion has claimed they have started selling them to other companies just design. But this is a quite new development, but there is quite a few other people thinking in the same way concerning how this can be done, and then you could potentially do 1 or 2 or 3. I guess you can't use the most expensive of these for the cheapest applications, but 3 connectors can offer absolutely any possibility on this. And then I think we need to involve, that's the next slide. It could be possible then in 5 to 10 years, if all equipment manufacturers have ended up with only PoE devices, you can have 2 types of plug, and you can run practically anything. Obviously, there is a need for a gradual transition. We can't go directly to that step, because there's not enough kit existing. But as you say, Sonora has started making PoE devices, and we are talking with 2 or 3 other major suppliers that also are prepared to start making them in more or less in a very short time. The electronics are really prepared for it. They're just on the device side, but they don't make them because no one has asked yet. So I guess that will take a couple of years. So users, operators, I guess SUT and NOSP, FFU, that type of, because we as the manufacturers can't run this alone. That needs to be coordinated on a higher level. And our input on that, we are preparing our next generation. You can see a mock-up of the micro MUX sitting out on the workshop side. And that on the single board there can offer each of these 3 times Ethernet gigabit, 8 logic lines, and you can also put an expansion bus to expand quite a lot on this, also including PoE boards later on. It's not in there yet, but it's meant to be able to do it. There is 1 of these boards in the micro MUX, and you can install 2, 3, 4, 5 of this in the big MUX. And also based on the development of SFPs that used to be 1, 1.5, 1.2, 1.5, they ended up on 2.7 gig, and I think we are now between 5 or 6. Do you want to say a number on this? No? No, 5 gigabit. So we can utilize, and obviously all these optical components also cost a bit. Also when you want to run optical muxing, the CVDM, coarse wave division multiplexer, that costs money. But now you can actually run a small MUX directly on 1 SFP. So that is the first implementation from our side of the first bits and pieces we are hoping can keep us running now for 10, 15 years without obsolescence. We are still having a big stock of what we are running on the current fiber optics, and we bought what we thought was an insane amount of components like 2 years ago, but also the sales of these have been following similar curves that Sonodyne has seen on the sprint nav. So I think last year we sold 4 or 5 times the average of what we did the 2 years before. So the stock is not running low, but it's running faster than we expected. So we need to implement these within a few years all over the range. The standard connector can be implemented based on industry input. So now it's up to you on that side. That's more like mission statement again. So, hit on time.
Thank you very much.
Okay. I almost got it on time.
Yeah, still before time actually.
Yeah, it could be a lot worse. So.
Very nice, interesting
Okay.
presentation, history, and hopefully the future. Any questions, anyone?
I could quote Alan, if you start asking about Ethernet, TCP, IP stuff, then you would call someone else. So we can decline. So. So very general questions we can do. So.
I've got more of a thought, I suppose, perhaps for the younger guys here, that a lot of the presentations tonight mentioned standardization, and I was at Yale recently for the Casino Vacuum conference, and there was a lot of standardization ideas there about software and workflows.
Yep.
In order to get efficient and work together to kind of use that energy and achieve climate goals and things. But it seems to me that it's going to be very difficult to do that, and for companies potentially to make money as well. I was just wondering, that's my thought. I think that's one of the main challenges we will have, is that companies need to be profitable, but at the same time try and drive standardization. So you're kind of losing your unique selling points because you go more standardized. So,
Yeah.
got any views, or anyone else got any views on that?
That's a very interesting discussion. Obviously, we are having that both internally and with other cooperating parties all the time. But I think both the general industry and especially Innova, and to some degree Sonodyne, they have been much cleverer to making at least a big part of their turnover standardized. But I think we are potentially down in the 20% of what we do is standard. We are aiming, we could easily move to 30 or 40, but the mindset in our company, there's a lot of things that still need prototypical approaches, but the building blocks we are using should to a higher degree be standardized. Somebody making a PC don't make a new USB connector. If you make an electrical device, you don't invent a new plug. And we try to move this a little bit forward. And the same with us, we don't need to make every individual PCB. There's bits and pieces here we can buy. Not on everything, but there are ways forward to. It's not like engineering. The engineering requirement will disappear when we make the first standard of this. I can guarantee you. So, is that an answer in the direction you? It's very interesting.
It's more how we can, like, for instance, the organisation put the standard for the telemetry together.
Yeah.
You know, that's going to be difficult because Sonodyne might want to do one thing, Conserve might want to do the other.
Yeah.
Everywhere we're going to come up against loggerheads because people want to protect their own interests.
Yeah.
And that's the big challenge, isn't it? It's overcoming this individual things working together.
Yep.
Yeah. I don't think there's any answer to that.
But as someone mentioned earlier on, the stuff we want to standardize here now at this stage, especially connectors. So there's no one here representing connectors, so they can't defend themselves. So nobody here loses out by standardizing on connectors. So yes, you can see that level. But there's other things here that also could benefit, obviously, from standardization. But I think we have to do this a step at a time. So if we can get these interfaces closer to standardization, that is something that will eventually have to happen in some fashion. So
a good example is electric cars. You know, and manufacturers have made non-standard plugs.
Yep.
In modern technology,
Yep.
and mobile phone chargers. Nobody's learning any lessons here. We're in danger of repeating the same thing over and over again.
Yep.
I guess we need enough garbage so that the European Commission comes and says this
Yeah,
is
yeah.
the standard.
when this comes to the European Commission, that's past our time, I think. Possibly into your time, but I don't think so.
That doesn't affect the Brexit.
No, that doesn't affect you. And they have the wrong plug in the wall also, so they are still on that side.
The right plug.
We can discuss that afterwards. It's a very interesting discussion.
Anyone else? No. All right.
Okay.
Thank you again, Terje.
Okay, thank you.
All right. So I think I didn't mention, but the title for today was the Internet of Things, Subsea Technology and the Internet of Things. I think I forgot that part. But very interesting presentations, different backgrounds, different products, different elements. I hope you all enjoyed and had a good time. We will be back with more events like you saw in the initial presentation. I think there is still food. Is there anything left, Steve? Yeah. Okay. Now it's becoming the business time and the networking time and food time. So I think I would like to call all the presenters, if you can, to come a little bit up front. And then after that, there is a workshop we have planned for everyone. So just don't leave the ring. So I think there is a plan for that as well, to bring some. For the persons in YouTube, I think you're really seeing my half of my head now. We're gonna open the champagne bottle. So if you are at home, feel pity for yourselves, and thank you for joining. See you then.